0.09068. Okay, where is the molarity of acetic acid? Molarity of acetic acid, 0.036. This is what I did. For you, you have to use your value, use your number. Here you cannot report this in your lab report. You have to use your calculation. So, but you have to understand, this is the molarity of your sodium acetate in your buffer, and this is the molarity of acetic acid, which is simply where we took 3 milliliter times 3 divided by 5 moles, and then find the molarity, and it comes out 0.036. No, sorry, this is 0.968, 0.92006. Okay? Now when you do the math, you will find your pH comes 5.17. pH comes 5.17. So not much change. Okay, do you know how to find now the pH of your buffer solution after you do all your calculation? Okay. That's the acetate buffer. This is the ammonia buffer. Okay, they want the pH of ammonia buffer, pH. Same thing, you have the same story, pH equal pKa loss log. What's the base for the ammonia here? It has NH3 here, concentration of ammonia over concentration of ammonium, ammonium. This comes from the ammonium chloride, so that's the NH4 plus, and the conjugate. We already find the concentration of ammonium chloride here, the molarity of ammonium chloride. Now here's the only thing here, what they give us here for this, given in the book, what they give us? Give us Kb. They gave us Kb equal 1.76. 1.76 times 10 to the power minus 10. No, minus 5, sorry. Minus 5. This is in your book, it's given to you. So the same, you remember the Kb times Ka equal 10 to the power minus 14. And you find Ka because this is Ka for this particular solution. So you will have 1.76 times 10 to the power minus 5 times Ka equal 10 to the power minus 14. And from that you will find Ka for this ammonia solution, Ka equal 5.6 times 10 to the power minus 10. 5.6 times 10 to the power minus 10. And then the same thing, so your pH will be, your pH equal, and the law, and pKa here for this value will be, when you do the pKa minus log that, and it will be 9.25. 9.25. So this will be 9.25 loss log ammonia concentration of the ammonium tank concentration. Where's that? Where's that? Molarity of ammonium chloride here. Molarity, so that will be 0.100 over, that's the ammonia, over 0.1346 for me. And you will find that, do the math, and you will find your pH for that ammonia buffer comes to 9.12. 9.12. And if you go back to this, if you go to the measurement, it was 9.67, the value was as. Okay? Is this clear here or not? You know where this comes from. So you rent this out? Okay, well that's good, you see. So see what's your number? It's not the same as.
No.
That's within. Okay. Okay, up to here. There's two more calculation, and I just will do one, and because the other one is the same. And that's also very important calculation because that's where it makes you understand how that buffer works. I mean, if you have your, if you really print your own, yeah, you can go do your calculation right away. That save you time if you printed your values. Okay, we go there. So you find, that's why at the beginning I was telling you those values are important. The molarity of the ammonia, molarity of the ammonium chloride, molarity of the acid, molarity of the sodium salt of the acid, sodium acetate. Okay, should we start the other one? Okay, move to the other question. The one before the last. Oh yeah, there's another one. Actually, there's 4 more calculations. Maybe I just do 1 or 2. Maybe I do 1 and let you guys do the rest of them here. Come on, I know you can do it. Okay, now let's see, because that's the whole function of the buffer. Will it resist change on pH or will control pH? Let me see what we can do. I want to keep this because I need those numbers. Okay. This is where it will require, they want pH of 50 milliliter acetate buffer plus 1 milliliter of 0.6 mole of sodium hydroxide. pH of 50.0 milliliter acetate buffer plus 1.00 milliliter of 0.6 mole of sodium hydroxide. I'm putting actually 0.60, so give me two. And report two significant figures, make my life easier for calculation. You can do report one if you want to. Okay, you understand now what's happening here. We have 50 milliliter of acetate buffer. We took a beaker here. Same thing, we have 50 milliliter, 50 milliliter, 0.0 milliliter of acetate buffer, and add to it 1.00 milliliter of 0.60 water in AOH. Here's, you need to write down first your acetate, how's the acetate buffer look like. Acetate buffer would be acetic acid here, OH plus water, and give you acetate ion plus hydronium ions. Okay, so actually, you have a mixture in your buffer of these two things here. What you need to understand, you have a mixture in this flask here of these two. You have acid and base. Weak acid and its conjugate base. Now you understand what you need to understand. When you add the sodium hydroxide with plus NaOH, that's what will happen here. This will just give you Na plus OH minus the hydroxide. So where this goes after what? Which now the hydroxide ion here, we add the sodium. Where will go after what? What will react? With that, with the acid. There's a proton here. So actually, this will decrease and it's from initial concentration. Concentration here decreases, and this will be increased. You understand why? You have you added sodium hydroxide. Sodium hydroxide is going to react with the acid. So your buffer here, the acetate buffer here, your acetates will go up because sodium hydroxide plus acetic acid will give you sodium acetate, and that will increase your acetate ions, and your acetic acid will be decreased. So if we know the initial concentration of this, that's all we need. And then subtract how many moles of the sodium hydroxide added there, and how many moles of acetic acid we started with, and how many moles of acetate ion we started with. And by the way, you can use this equation either by molar or moles, because you see the volume will cancel. It works. You know, you can use this instead of the concentration. You can do it in terms of number of moles of acid, moles of the acetate ions and moles of the acid ions. So